Hello, today I'm going to talk about AWS TGW Connect attachment. This is one of the things that AWS recently launched, and I was trying to use it for one of the use cases that I was testing for work. And while setting it up, I realized that there is not much good material out there in terms of what it is, what's the use case, and then how do you configure it. So I usually don't make videos. This is probably the first time I'm making one, and but I'm a big time user of all those awesome technology videos that are available on YouTube. So this time around, I thought that this is my time to contribute to the community and maybe help people out who are looking to set this up. So before we go and talk about the TGW Connect attachment, I just want to quickly summarize like what are the different attachments available on TGW and what are the use cases for those. So first of all, there's a VPC attachment. So as the name says it all, that these are the type of attachments where the users can use it to attach their VPCs to the transit gateway and use transit gateways to transit the traffic through that into the VPC. You can also set up inter VPC communication through that, or can bring the traffic from other attachments like VPN attachment. So VPN attachment is typically over IPsec, and that type of an attachment basically comes from the on-prem branch where a router is sitting and you are terminating over an IPsec connection into the TGW. Then there is this TGW attachment. So basically, a TGW can peer with another TGW using this TGW attachment, and usually these TGWs are in different region, so that you can use the Amazon's backbone when you do inter TGW communication. And the last one that we're going to talk about today is Transit Gateway Connect. So what is Transit Gateway Connect? So this definition, I'm basically copying it verbatim from the Amazon website, where Transit Gateway is a new feature where it simplifies branch connectivity through native integration of SD-WAN. So what does this mean? So the topology below, this is the one that I created, and I'll demo to you how to set it up. We'll explain like what's the use case and elaborate it further. So what you see on the left hand side is actually a bunch of VPCs. These are host VPCs where the applications and the workloads are running. They are connected to the transit gateway over VPC attachment. And then there is a transit VPC that you see where the SD-WAN appliance is sitting. So that transit VPC, you can actually, the SD-WAN appliance that is sitting into the transit VPC, you can actually set up a TGW connect to it. In order to set up a TGW connect, you need to first set it up as a VPC attachment. So the transit VPC get added to the transit gateway as a VPC attachment, so that the subnets that exist in the transit VPC can get advertised to the transit gateway, and using that you can actually build a GRE tunnel using the private IP addresses. One question that pops up, which again popped up in my mind as well, that usually before the TGW Connect, the typical design in this kind of a scenario where the SD-WAN is sitting on the right hand side, is that from the transit gateway, customers were actually setting up an VPN attachment into the SD-WAN appliance. From a architecture perspective, yes, it works. The traffic can flow from your branches into the SD-WAN overlay, then to the SD-WAN appliance, and then to the transit gateway over VPN attachment. But that VPN attachment comes with its own limitations. Like for instance, each VPN attachment which is over IPsec, you cannot go over 1.25 gig of throughput. You need multiple of those for ECMP. When you have multiple of SD-WAN appliance, so you can just multiply by 2. And the shared throughput, like for jumbo flows and all that, does not work with that IPsec. So with the GRE, which is a much more lightweighted encapsulation, it actually helps to do higher throughput and basically don't have any processing cost there. So this is the whole idea about TGW Connect, which actually enables you to extend your branch connectivity from SD-WAN using SD-WAN through this transit VPC in a much more cleaner and a much more efficient design. Now we'll move to the demo, and I'm going to talk about how you can actually configure it. Now for demo, we're gonna work on this TGW, which is TGW Connect testing. One thing that we want to make sure before we start is that there is a subnet assigned to this TGW. This is required for TGW Connect attachment. So the way we can check it or add it is select the TGW, select modify, and at the bottom you see that the subnet is assigned. So the outer IP address for GRE will be picked up from this subnet. You can add more subnets as you like. But yeah, just make sure that the subnet is attached to the transit gateway. Once that happens, now we go to TGW attachments. What you see here is we got two attachments here. One is the VPN attachment, and one is the VPC attachment. So just for the demo purposes, I have a VPN attachment, which is again running an IPsec tunnel from a CSR into the TGW for VPN attachment. And then the VPC attachment also has a CSR inside. So once we run the GRE inside that and do a TGW Connect attachment, it's going to get terminated onto the CSR as well. Now with that, we will create a transit gateway attachment. We have to pick the transit gateway ID. We have the only one in our account, so that's easy. This attachment type will be connect. If you like, you can give a tag to it, and then you have to give the transport attachment ID, which in this case will be the VPC attachment. So this GRE, again, I'll repeat, will be running on top of the VPC attachment that we already have. And then I'll just do create, and it will go ahead and create this attachment. It takes a few minutes, but in like in this video, we're gonna skip that and fast forward it, and then we can move to the GRE configuration. So fast forward, we are back. Now the TGW Connect is associated here. We can name this attachment as TGW Connect. And now the next step is to connect the peers. So here we will create a TGW Connect peer where the GRE will be terminating. Similarly, we can give the name tag. The first one is the transit gateway GRE address. That's again going back to the subnet that I talked about. So it could either be auto-generated, that IP address, or you can manually assign the IP address. Then the peer GRE address is the GRE address for the CSR that is running inside the VPC. And then we can provide the BGP inside IP address. This is the one, the 169 address, which we use for the GRE, and the same will be used for the BGP. It needs to be a 169 subnet. Here in the info, it shows that what subnets, what ranges we can use for it. So we'll do 169.254.10.0. It needs to be a /29. We don't want to do IPv6, and then it needs to we need to provide the peer ASN. So here my ASN on the TGW Connect side is 65533, and we'll do a create. So now this will create the TGW Connect attachment. We will wait for this pending to complete, and once it completes, then I can go ahead and configure my CSR with these with the GRE and the BGP configuration. One thing interesting that I find out when I was trying it, that for the BGP configuration, we need a eBGP multi-hop statement. It might be going through multiple hops within Amazon network. Without the multi-hop statement on the VPC, on the CSR running inside the VPC, I was not able to get the BGP up. So that's one thing that we'll need here. So now you can see that the TGW Connect peer is available inside Amazon. Now we can go to the CSR inside the VPC attachment in order to configure our TGW Connect GRE. And here are the configurations and the IP address that we need to use. So now going to the CSR, which is running inside the VPC attached, if I do a show IP interface brief, I only have two interfaces. Then and this is the other CSR which is coming over VPN. If I do a show IP route, I don't see any routes being learned from BGP. So let's start with the configuration. So I'll set up a tunnel 1. Let me see the IP address that I need to pick. This is the BGP peer IP address, which will be my GRE tunnel IP address. 255/29, which will map to 248. Then I'll give the tunnel source, which is my local IP address right here. My tunnel destination will be from that TGW subnet, which is right here. Will be my outer IP address. And then if I do show IP interface brief, I have my tunnel up and running. And in order to quickly test it out before setting my BGP, I can try to ping those IP addresses. So the second one is this one, and then the third one is number 3. So now let's go ahead and set up our BGP. Our BGP 65533. Oh, I spelled it wrong. Router BGP 65533. Here you go. Neighbor is 2. Remote AS on the TGW side is right here. I'll pick that, and then boom. Neighbor 160. eBGP multi-hop, address family, IPv4, neighbor, activate, exit. Now I'll do the other one, neighbor 3, remote AS 64512. Then I have to give the eBGP multi-hop, and then activate the neighbor activate. So I think this should do it. Show IP BGP summary, boom, we got it. Now if I do a show IP route, I see the route from my remote CSR, which I can validate right here as well. If I do a show IP route, boom, I see my other route as well, and this is the connected which I'm learning. So now let's try to ping this guy over TGW Connect. Oh wow, I see what's happening. I think it's the source and the destination check is disabled since it's a loopback on my other side. Let me try to ping the other way around. Give me 1 second. I'll try to ping it from the other way around. So since this CSR is also running on the AWS, so if I do a show IP interface brief, and this is my loopback. So AWS did not allow to ping any IP address other than which are actually assigned to the interfaces. So in this case, this is a loopback. I have to disable the source destination check in order to allow this ping. Yeah, let me try the other way around by doing a source 10.20.20.20, and boom, it's working. So this is all. So all we did here is to give you a brief overview around how the TGW Connect attachment is set up. So if you have any questions, just hit me up through the contact details on the video description, and I would be happy to answer any questions. So see you next time. Thanks for watching.